You know, like it's the original controller. So I was like emulating it house and trying to get it and like project, but it's this was HTTP. The new one.
Was it in Vancouver or is the conference?
Yeah.
Oh, really?
I've only been to Mexico. Never been to Canada.
That's funny. Not even like Niagara.
What's that?
Not even Niagara.
I've seen across the way.
It's very exotic.
Yeah, let's go.
We bought a Groupon to go to a hotel up in the get up there, we started seeing the reviews so that's the owner's son just calls us like coming over like this is Betsy your name. And then like we call for champagne like all of it and water like he's a crazy person. They didn't want to finish the closet. They just took it back through the handles they don't burn.
That's weird.
It was amazing. And then like we went to go check in like we don't have this.
I really don't know to be in
Now we're in the Godzilla hotel, so from 12 to 8 on the hour, Godzilla's head smokes and roars. So,
Okay. Let's get everybody excited. Okay. Hi everyone. Thank you for coming out. Smaller crowd tonight, but we have a nice audience watching online tonight, so that's good. Thank you for coming out. Tonight we've got 2 talks, if you didn't know. Britt's gonna start talking about deployments that are just so easy that developers are gonna ask for them by name. And then we got Chris Scott talking about programming language of the mind, developing a programming language of the mind. So I'm just going to let it get started so that the online audience isn't waiting too long watching the live stream that's doing nothing, and let Britt get started.
Oh, thank you so much, Justin. Hi, everybody. Thank you so much for coming out tonight. I really appreciate it. Special thanks to Code and Supply for allowing me to do this because I am prepping in 3 weeks to go to Confu, which is a polyglot conference in Vancouver. It is the first time that I'll be speaking at a large conference, and I am undoubtedly nervous. So I really appreciate Code and Supply letting me do a test run of this. I will be asking your feedback at the end of the presentation. Please, I want all the feedback that you have. Another interesting thing, the week before I go to that conference, I'll be headed to Vegas, and I am currently studying to become a certified AWS developer. And so I have been rigorously training for that exam. And so we're going to be talking about AWS CodeDeploy tonight. And so this has definitely been part of my training. So let's address who am I? So hi, I'm Brittany Martin. I am a developer in Pittsburgh, born and raised. I just got married less than 2 weeks ago, so that's pretty exciting. Thank you. That is me pictured in front of a replica DeLorean from Back to the Future. Really got to own it. So, okay, so I am, like I said, a developer. So I got my start through a boot camp almost more than 4 years ago. And so once I graduated, I started working for a hosting company as a customer support engineer. And a big part of that job was SSHing into servers and solving clients' problems. So I spent a lot of time, bare metal, had no idea what I was doing. Before I even understood what the job meant, I was doing SHH. And so my coworker would be like, it's not it's SSH. So anywho, I spent a year doing that, and I've just developed an appreciation for DevOps, and I truly believe that it has helped me in my career because a lot of developers nowadays that are learning how to code just don't consider learning how to deploy on something that's not Heroku. So anywho, DevOps is awesome and it is a big part of the reason where I am today. Speaking of where I am today, I am the lead Ruby developer at the Pittsburgh Cultural Trust. If you guys have ever attended a show in the Cultural District or outside the Cultural District and bought your tickets online, I have written. So I love my job. It's a dream job. And let me tell you about my team. So our team is only 4 people. So Patrick, my boss, is the director of e-commerce. I am the back-end web developer. My partner is Danielle, and she is the front-end web developer. And then Justin Snare is in charge of our cloud operations. So we service a large app in order to service all of these districts. So within the Pittsburgh Cultural District, we have 10 different organizations that we're selling tickets for, all underneath one application. So when you visit the Pittsburgh Symphony site, you're actually on the same website as if you went to go visit the Cultural Trust to buy tickets. So it's all one application with 10 different phases. So it's very important that we have a high availability for this, and it's important that our deploys go smoothly for this. So our application is built in Ruby on Rails. We are hosted on AWS. We use a lot of jQuery for our animations on the front end. And then we are connected to a proprietary nonprofit service called Tessatura. It is our CRM that we do all of our ticket transactions through. We are the only Ruby on Rails app in the entire world that's connected to Tessatura. The rest of them are all connected via .NET. So it's a cool little fact about us. We use a ton of AWS services, all the way from EC2, CodeDeploy, Elasticache. We use Omniture for our analytics, Travis CI to run our tests, CloudFront to cache our assets, CodeClimate to make sure that our code is written well, and then we use GitHub for hosting our code. So this leads me to talk about deployment. And deployment is a very important thing for us because we do need to have high availability. So why use a deployment service? Well, it's very important that you're able to manage complexity, that you're able to automate those deployments, and that you can avoid downtime. For us, downtime is crucial. For us, Steve Martin and Martin Short went on sale today. Within an hour, we did $100,000 worth of ticket sales. So it's very important that we have high availability. And a lot of times these on sales will happen without us even knowing. So we need to be able to have good, clean code ready to go. And so this led us to start using AWS CodeDeploy because we were already hosted on EC2. It's really simple to get started with AWS CodeDeploy. You just choose an application revision, and in this case, it's going to be your commit. You can scale your service from 1 to 1,000, so you choose how many servers you want to spin up using that code revision, and then you can actually watch the deployment in real time in the console or through the web portal. It's easy to queue your code. So currently, AWS CodeDeploy will help you with if you store your code in Amazon S3. I don't know of anybody who does that, but if they do, that's really cool. So you could essentially upload your code to an AWS S3 bucket and deploy it from there, or you can use GitHub like we do. In order to set up AWS CodeDeploy, you basically need to sit down and really think out how you deploy your code. So for a while there, we were using Capistrano, and it was kind of buggy and annoying for us to maintain. So then we actually started deploying our code manually. So it was very easy for us to outline the steps. But basically, you want to sit down, basically pull up a bare server, and just think about the one-by-one steps that if a robot were deploying for you and you were not available, what are those steps that you would need to take? And you need to write that into a script that you check into your code. And so you design that app spec.yaml, which I'll touch on in the next slide. You set up the AWS group that you want to deploy to. So for us, we have a fleet of EC2 servers that are sitting behind an elastic load balancer. That elastic load balancer is what's in charge of sending the traffic to the most available EC2 instance. So when we deploy, we basically tunnel our vision towards that group, and we deploy there. And then for us, we created a Slack notification so that when one of us deploys, we get a notification letting us know that we've deployed and then what the status of that deploy is. So this is an example of an app spec.yaml. It's just saved into the root of your application. And so you can you basically have different places where you can run different scripts. So you can do something before you install your code, you can do something after you install your code, and then you can do something in order to start up your application. I realize that's a little funny, a little fuzzy. I'm gonna have to get a clearer picture for that one. So the way that CodeDeploy works is you have a CodeDeploy agent that sits on your server, and every time you deploy, it basically wipes out the code that's on your current server and then pulls down a fresh copy. So for any reason you went into your server and you made a change to your code in between deploys, when you were to deploy again with AWS CodeDeploy, you would lose that change. All of your changes need to be committed to GitHub or that S3 bucket in order to remain on that server. So every server that you spin up is then going to have that code deploy agent. And then if you were to scale up how many servers you have underneath that group, what happens is that AWS will bring up a new EC2 server, and then code deploy will actually deploy fresh code onto that server. So instead of copying an old server and then just bringing it up, it will create a brand new fresh server, no logging, everything's clean, and then it'll deploy that code deploy code onto it. So you can choose your speed in which you deploy your code. So you can do it all at once, you can do half at a time, or you can do one at a time. For us, we prefer a half at a time. Because we're a Ruby on Rails application, we have to use a pretty extensive precompile, and that takes up a lot of memory, and so we don't want all of our servers hogged up with that precompile all at once. So we choose to do usually half at a time, and if we're deploying to our staging server, we'll just do all at once since we only have one server. So the way that it sets up, so you're going to set up that deployment. You go into the AWS console, you select which app you're going to be deploying, and then you choose what commit that you want to deploy, and then you trigger the deploy. You'll be able to see in AWS's logging service, which is called CloudWatch, your deploy going through. You're basically going to see your script being executed, and then you're going to get that push notification to Slack should you have set one up. So you're going to probably giggle at my notification that I have in Slack. It's just straight JSON. I have not made it pretty at all. But basically, every time someone from my team triggers a deploy, we have a channel in Slack that deploy is getting posted to. And then after about 20 minutes, which is how long our deploys typically run, we get a success or a failure message. And then we're able to go into our CloudWatch logs and to see why it was successful and why it's not. So all code deploys follow a pretty similar process in terms of the deployment. So you're going to have that start. It's going to stop the application that's currently running on that server. It's going to download the bundle, and by bundle, it's downloading that code from either GitHub or your S3 bucket. It's going to run your before install script. It's going to install your code. It's going to run your after install script, which you might not have anything. That's completely optional. It'll start your application. It will validate that it's healthy. And so in our case, our Elastic Load Balancer knows that if we have set a URL on each of our servers, that if it doesn't come back with a 200, it's unhealthy, kill the server, get another server, and then deploy again. So we'll validate the service, and then we're shipped. So since we do that in a rolling deployment, we don't have any downtime. As of September 15th, so CodeDeploy is a relatively new service for AWS. It's been around since maybe late 2014, so they've been iterating a lot on it. But as of September 15th, there is automatic deployment failure rollback. So like I said, before they would have just killed the server and then brought down a new bundle of code. But you can actually, you will go backwards to the last version that worked on that server. So if you deployed something buggy that will cause that heartbeat check to not register at 200, your servers will automatically roll backwards to the last deploy that worked. Okay, so what happens if you deploy something buggy and everything goes to hell? So basically you pull the curtain back and it's empty, there's no one there. This is a joke because I work at the Cultural Trust, insert laughs, and anywho, so this has happened to us before where our deploys took too long. So the way our Elastic Load Balancer is you need to have a successful server response within 30 minutes. And when we were in process of upgrading our Ruby, it took too long. It took around 40 minutes. So essentially what we needed to do was scale down to one server. We usually run about 4 servers at once. We needed to roll back to the previous version of the code that was working, and then we needed to go into the server and manually upgrade that Ruby and then get it passed. For the next deploy, we ended up increasing the amount of time it would take until that heartbeat was okay. So we ended up increasing it to 45 minutes, got past that upgrade on Ruby, and then went backwards. The key thing of this is that CodeDeploy is all about how you're using it. So it's important that you have a staging server set up where you're using CodeDeploy already so you can see how long a deploy is typically going to take you, and to make sure that if something were to happen that you have a backup. Another thing that happened to us is we all know that the DNS outage that happened about 3 weeks ago. Well, since we pulled our code down from GitHub, we went to go scale for another on sale, and all of a sudden we started failing because we weren't able to grab our bundle of code. Luckily for us, because we work on our machines locally, we were able to push our code up to S3 and then deploy from there. So we always recommend, as developers, that you always have a backup plan. We never guessed that the kink in our system was going to be GitHub. And it was good because we needed to scale upwards. We didn't have to deploy a fresh new version of our code. Luckily, we weren't trying to solve a bug or anything, but I think it was a really good reminder that you always need to have a backup. So here's the money question. So how much will AWS CodeDeploy cost me? The answer is free, but you have to pay for the resources that you are deploying. So it is a free service should you be using AWS already for your deployments. I highly recommend giving AWS a try. Has anyone not used AWS before? Okay, cool. So if you've used Heroku before, Heroku sits on top of AWS and basically provides you an interface to deploy onto AWS. And so AWS is far cheaper if you use it directly. And it's always great in terms of job hireability to really learn how to deploy onto bare servers like this. So I like CodeDeploy because it kind of gives you that interim between Heroku and then just SSHing into a server and doing it yourself. Okay, so that's all about AWS CodeDeploy. And now I'm going to throw in some bonus points. I'm using a really cool service that I want to tell you guys about as well. I use something called Dependabot. It's for dependency management. So because we're a Ruby on Rails application, we always have to be updating our gems, whether it's security problems, whether or not it's vulnerability problems, or it's just general things falling out of date. We constantly have to keep updating our Ruby on Rails applications. And so we maintain 2 applications at once. So you can imagine that we have to bundle update quite a bit. And if you aren't familiar with the Rails community, gems are the libraries that you install into Rails, and they constantly get updated. And so what happens is you really do weave a difficult web should you not keep up with it. And so what can happen is you can bundle update your gems and have a failure because now one of your dependencies is out of date, and now you're depending on another dependency that's out of date, and it just becomes absolute hell. So we use something called Dependabot. What Dependabot does is it will scan all the gems that you use in your repository, and it will actually bundle update for you, and it will create a pull request and submit it to you and assign it to you, which is really, really nice. And so Dependabot really likes to brag about itself. So every time it submits a pull request to you, it likes to tell you how much time it saved for you. In this case, Dependabot on this application has saved me 2 hours and 57 minutes. But the thing I really like about Dependabot is it always links to the changelog as to why that gem is getting updated. So if it is a security problem, I know that I need to schedule a deployment in my schedule soon. If it just happens to be a thing where someone removed white space, then maybe I'm not going to schedule that deployment so quickly. But I really enjoy Dependabot because we have a hook into Slack. So as people are submitting pull requests, we'll get a notification in Slack. Dependabot really likes to work on Saturday night. I don't know why. So I'll get a notification, be like, oh, my coworker's at it again. No, it's just Dependabot, and it's bragging again. So the way Dependabot works is it does review for those updates on your schedule. So it reviews for updates on a schedule that you choose. So for all of my applications, I ask Dependabot to scan our gems once a week. You can do it every day. You could do it every 2 weeks. You can do it every month. If it finds something needs to be updated, it will then create a pull request and then assign it to you. You choose whether or not that's something that you want to merge in. You merge that pull request in. Because our pull requests are integrated with continuous integration, so our tests always run, and Code Climate, which is our linter to make sure that our code is clean, I can see whether or not the pull request is valid, which is really nice. And then next time we deploy, our gems are updated, and I don't ever have to I never have to type the words bundle update. So the whole point of this talk is that I really want to make sure that you're focused on building and writing code and not deploying. So thank you very much. I would very much appreciate your feedback on this talk. Again, I'm doing it in 3 weeks, so if there are certain things that you wish I had not covered or covered, I would really appreciate it. That includes the folks at home. If you can please either message me on Slack under the Code and Supply channel, I'm Brittany Martin, or you can email me or direct message me on Twitter. Thank you all very much. Cool.
Thank you.
Thank you. Questions or?
Jess Nebkin.
No.
Nebkin? I'm sorry, Jess. She said hi.
Oh, great. Awesome. Okay, cool. Did anybody have like any direct feedback, or you can grab me? I know there's a break in between, right?
Yeah, there is. Although Pizza's not here, so we may roll a little early, depending on what I said in the schedule. I want to give people a chance to get here if they wanted to just see Chris's. But yeah, let's,
Your slide back up.
Oh, sure.
So that,
Oh, yes.
the
Good
one
call.
with your email and stuff. Yeah.
Yes. Cool. Good call. Yes.
How do you define a successful deployment?
Oh, great question. So that means that all of these steps that I've written in that appspec.yaml, which is my script deployments, are successful. So no errors on those. So that involves for us a lot of rake tasks and, maybe migrating the database, pre-compiling our assets. And then once the code deploy process is finished, we have a URL on our app that we hit. It's called /heartbeat. And so our Elastic Load Balancer will hit that URL, and if it gets a 200 response, that deploy was a success. Good question. Yes.
So you were talking about the problems you had upgrading Ruby.
Yes.
I'm curious, I would have assumed that you would have upgraded Ruby in the AMI and then saved the AMI and then deployed with a different AMI? Is that possible?
That's a great question. So
What is the name of it?
Amazon Machine Instance. So it's kind of like a Docker sort of thing, right? Where you can like create a instance of the machine and save its state. And then every EC2 instance you spin up uses the same AMI. So you can like update your operating system or update different code dependencies every machine is going to use. And have that be separate from your application.
So in order to update the AMI, you actually have to take the app offline. So we were trying to do it in a way that wouldn't take the app offline. So what we did is we temporarily added the Ruby installation code into the appspec.yaml. So as part of the code deploy process, it would upgrade itself to Ruby, still staying online, and then it would go through the code deploy process. And that ended up taking longer than expected. If we had done it via the AMI, then we would have had to basically scale down our site, take the app offline, create a new AMI, and then put it back into the group and then go back up. So we would have had to go down for maintenance, probably at least for 20 minutes.
So in the code deploy, you can't set the AMI version to deploy to.
Correct.
That's kind of dumb.
Like I said, new service and great feedback. I'll definitely address that in my talk.
Yeah, I mean, if you were on Docker, it'd be fine. But if you're relying just on
Yeah, we use Nginx and Passenger.
well, the Docker.
Oh, yes, Docker container, correct?
Then
Yeah,
you have,
we use an Ubuntu machine.
well, Docker,
Yes, also in Docker.
Yes, yeah. So Docker can run on any Linux environment.
Right.
Yeah.
I've been meaning to look into it. I wonder if it makes sense for our organization. It might.
It makes a lot of sense for a lot of scenarios because you take all of your application code, everything that is required on a machine to run your application code,
Mhm.
and then it becomes system agnostic. So you can pass it to any developer, any machine, anywhere, and as long as they can run Docker, they can run your entire application. So it would have like your Ruby version, it would have like application code, it would have image magic, or anything else that you require already installed into the version that you want. So when you went to go do a deploy, instead of like reinstalling everything and hoping that it worked, it would already be there.
That sounds cool. I'm going to a container workshop at reInvent, so I will definitely check that out. Thanks for the advice.
The biggest headache is networking.
Yes.
Showing that the biggest reason for the security update in most systems is the code.
Can I ask how the zero downtime mechanism works?
Yeah, so just to repeat for the folks at home, I was asked how the zero downtime mechanism works. So basically what it does is it will take servers one at a time and it will leave, so say we have 4 servers underneath our Elastic Load Balancer. And so if I do half at a time, it's gonna take those 2 servers out of the group and it's gonna deploy to them. And then once they have a success, they're gonna go back into the group. And so you have 2 servers that at a for a while they're handling all of your traffic. So that's why we typically tend to deploy early in the morning when we have low traffic.
But your staging server, right? It's just the one server.
Correct.
It couldn't do a zero downtime deployment, right? It would have to come offline.
Correct. And what's really funny, and actually I'm really glad that you asked this, if you have a staging server with one server, or if you just have an environment with one server and you deploy half at a time, code deploy actually fails. They, for some reason, do not have some sort of check to make sure that the servers can be divided by 2. So it will just full on fail. We've all made that mistake before too, which is really funny. I'll have to include that because it's really funny. It's like a little kink of it. Yes.
Are you doing any like CloudWatch auto scaling?
We're doing any CloudWatch, I'm sorry?
Auto scaling?
Oh, yes, absolutely. So when our CPU hits a certain amount, we auto scale, and when our memory hits a certain amount, we auto scale. We have New Relic installed in order to monitor everything. We also use Skylight so that we get a weekly report on how our code is performing. But yes, that is absolutely a thing. So we also manage, something I didn't talk about is we manage the festivals as well. So if any of you have gone to First Night, Three Rivers Arts Festival, the Children's Festival, or any of the gallery crawls, that's a separate Ruby on Rails site that we manage. That one definitely auto scales all the time because you can imagine we get the majority of our traffic in a very small window of time. So when you're on the gallery crawl, it's very likely that you're going to pull up the website, but it's not likely that you're going to pull up the gallery crawl website a week later. So you can imagine Three Rivers Arts Festival also goes up and down as people are choosing the band schedules. So we do have the festival website also under CodeDeploy. So should it auto scale, what happens is a new server comes online, CodeDeploy deploys to it. Should it be successful, it joins the group.
Okay, so when it auto scales, does it scale to the old version of the code?
It scales to the latest successful version that AMI has.
Okay, so you won't end up with something crazy where a user can hit like 2 different forms.
No, thank goodness. Yes. That was actually a big fear of mine when we crossed over to CodeDeploy. And something that I should also touch upon in the talk is that we used to have a custom application that deployed for us. And it was broken when I joined the trust, and it was part of my job was to like upgrade it and get it working again. And when I looked at it, I realized it was doing the same thing as CodeDeploy was. It was just connected to the AWS SDK. And so it was doing something very similar, but it wouldn't have had that technology to know like the latest version that worked and things like that. So it was really nice to be given a ticket and told to upgrade something and be like, why don't we just throw that app away? So I'm a big fan of using services if they make sense to replace the things that you already have in your infrastructure so that you can focus on the proprietary code that you really want to work on. Yes?
So one of the questions that I always have, whenever I'm starting a new project, I always have difficulty figuring out which paradigm to use, like, because there's also Elastic Beanstalk.
Yeah.
Like, well, that's kind of the same but different. And then there's like, you can do Docker and containers and like deal with all that different, wholly wonderful but also awful mess in some cases.
Yes. No, that is a wonderful point. And because I've been studying for that associate developer exam, I actually had never used Elastic Beanstalk before, and I was definitely curious of it. It literally is the same thing as Heroku. It is just cheaper because you don't have all the bells and whistles that Heroku gives you. But yeah, I think Elastic Beanstalk could be appealing in this case. But I'm doing some custom stuff on the servers that I like being able to have the freedom to adjust that scripting file however I please. I suspect I wouldn't be able to get away with that on Elastic Beanstalk, but on my next Ruby on Rails app that I need to deploy, I think I will try Elastic Beanstalk to see if it works. And I imagine Elastic Beanstalk and CodeDeploy are going to become very integrated very soon, because it seems like more and more people are using CodeDeploy, and I think they're going to start integrating it into more services, which is really nice. Good question, though. And I agree with Docker. Like, I feel like it's something I should be using. And we have an operations team at the Trust, and they're pretty wary of Docker, but yeah, of course. So it is something that I do want to try as well.
Do they have specific concerns about Docker?
Not, I think, just unfamiliar technology that you're bringing into the stack. I mean, our ecosystem that we've been using has been pretty stable for a long time, and it's not made him get up at 2 a.m. So, okay, cool. Thank you. Oh, yes.
First off, I have some feedback.
Oh, please.
I thought, so the tech stack was impressive. Your slides are slick, and the talk was well paced.
Thank you.
I wish everybody at large conferences is doing what you're doing, because...
Oh my God, you just made my entire world. I tend to talk too fast, so I appreciate that.
Yeah, I guess you could slow down a little bit, but otherwise it was,
okay.
it was really, really cool. I just have one question. So you said, you noticed one time that the deploys were taking too long.
Yeah.
So did you ever figure out what was taking? That
was when we were upgrading Ruby as part of the script. So when we were trying to be fancy, an upgrade. We included a new part into the script where it was actually upgrading passenger as part of the deploy, and then we were going to comment it out on the next round, and that's what was taking so long. So our deploys typically run around 22 minutes. I would like to find a way to, our precompile is 18 minutes of it, and I would love to pull that down, because it's a lot of times it's precompiling code that hasn't changed, and so I'd like to find a way to limit that for sure. Yeah, good question.
Some idea on that precompile.
Yeah.
I had an app that did the same thing, and what I did was I set up in my CI, I set up a script that could actually precompile in the CI and then check it into GitHub.
Oh, that's cool.
Yeah, and then it would just pull from GitHub precompile.
I actually really like that idea, because we could use something like S3 or EFS. I mean, we're already using S3 to, because it's the same thing that needs to be on every, it's going to be the same for every server. So it's not like there's going to be a difference anyway.
If you have like a thing that if all your tests pass, all the tests pass, okay, build script, check it into GitHub, and you can drop it, you can even dump it on its own branch if you really want to.
Oh, that's a good idea. So would it have been helpful? I thought about like generating a GIF of actually showing me going through the console and doing the deploy. Would that be interesting, or is that like, don't show me how to go through a console and how to deploy? Would that have been interesting? Yes, no?
Yeah.
Yes? Okay.
Yeah.
GIFs? Okay. Okay, cool. I will definitely do that. All right. Thank you guys so much. I really appreciate it. Ooh.
And that timing works really well. Pizza's here. I encourage you to, eat some pizza, mingle, and then we'll get started in about 10-15 minutes on Chris's talk, learning programming languages and comparing them, and it's going to be really cool. All right, let's get you plugged in.
Well done.
Thank you. I'm
You
excited for
can
your
tell that
talk.
You put on your homework on that one.
Yeah, that was very good.
Is this your dongle?
That's the code. Okay.
Would it be noticed constructive and helpful? I'm actually trying to find the link in recent chat. Unfortunately, you just closed the channel. But I'm looking to get the link to the fairly good job of discussing some of the comments we talked about in the workshops. Some of which were flaws of the guy using it in an understanding model, but chunks of it were like Docker keeps changing how everything is done, forcing jump through loops and things, change package formats, change tools, change that version. It's not a stable platform. I'll get the link rather than make ad hominem attacks, so I can point to something that's presented it all clearly, which I think would be better than just sneering.
I don't like that you have to run a Docker container. If you're on a Mac, it runs Docker containers for like Redis and a Docker container. Yeah. Postgres, because you can't get to your phone. Yeah. One of those things. They had to remove cluster fire. So basically,
Oh, God. He likes to do it. We all fire.
Oh no, I've got a few bags. Sorry, we just.
Also, hopefully that they get that will confuse me with like information that no one else knows. Be like, wow. Hi. Yes. I'm Brittany. So nice to meet you. Oh, you're fine. We'll just go away.
But it's super great because you can't outsource code to work.
we're being like, I had 15 weeks. If it's like, I have 4, I have 2. They're all frozen, which I've never frozen students before. So bad. I felt bad because I had some students start this week. I'm like, yeah, gosh, I'm freezing you next week. So, enjoy. Yeah, you're gonna get a break because you worked so hard. I feel like they're all very nice. Really did.
You can still work.
I'm going on my honeymoon next week, and so since I teach at night, I have to freeze all my students because I'm not sure what my Wi-Fi is. Plus, you know, I don't like working. Yeah, exactly. Well, I take my students a little too seriously.
That does not surprise me. I would have not been. I would have been like, oh yeah, she's gonna be doing intermission.
Jeff says that every time he meets me, I either yell at him that I need to talk to a student or I'm deployed to work. It's like, that's all I'm gonna tell me. I've never said that, but maybe I have. They had someone else for Rails and that did not go on. They actually did get it because they get a full-time member. That's it. But I mean, you can't have that. You have someone who's going to answer all the time. Yeah. No, actually, full-time mentors are it's actually
They be full-time.
that's what they meant. They meant like I should be able to
No, you can't do that.
Have you talked to students yet? Oh, great.
I don't remember his name, but he does like science and but it's really interesting because he
Oh, really?
record no matter what it is, and use that kind of and then you have a computer
Got it. Okay.
processes on top of that.
You remember having to do free source code?
Right?
Yeah.
So
They eliminated all of it.
Yeah, I don't do anything. So it's all like, and then like, yeah, it's also like,
It's good.
yeah, I think I'll.
I don't know why code school has.
you can get around a lot of
I got a new student yesterday, just graduated high school. I was like, hi girls. And I go, where do you live? She's like, oh, she's like, yeah, I think some of their jobs there. My God. I was like, my God, like, absolutely no reason. She's like, some of them. I was like, oh, where are you right now? And she's like, Arlington, West Virginia, or no, Arlington, Virginia. And I was like, oh. I was like, you're close to DC, you're there.
Make sure the live stream's ready to go.
Oh, yeah.
Yeah, I didn't even notice that you started doing that.
I've been doing it for 2 months or so,
Yeah.
consistently. We've been experimenting for a long time.
Will you have like offline video that I can have? Awesome.
Yeah, it streams to YouTube, Twitch, Periscope, and Live Coder
Cool.
all at the same time.
Wow.
And then YouTube will archive the thing.
Okay.
Twitch probably does too, but I found Twitch archives not to be that reliable.
Right.
but the YouTube ones are. Sometimes the titles are messed up, but the content's there.
Oh, that's the important part.
Yeah.
And does it? Do you split between like speaker views and the slides, or just is it just the video?
You can see it right here. It's well, this is not. So I have a few scenes. This is the one. This is the one that's typically on. It slides with the speaker up in the corner. And then if I find more speaking, I'll do that. Or there's camera only there. And this is what's on there right now. Like this is streaming right now, so if someone's seeing me go through them all.
Have you ever done a talk on setting all this up?
I should. I learned a lot, especially the actual video encoding settings that you have to do to make it work well. But I don't know if I'm at the point where I'm giving good or bad advice yet. So.
Well, I think for a lot of people like me, we do it internally. And I wish we had something, even just split video.
Yeah.
That would be really cool.
Yeah, I'm trying to grow CodeDeploy to be more the national thing where it's just the video content and we do the local events we do are more hands-on things. So this is like the studio audience for the live show. And then we have events that are hands-on like social events that build the community here. So yeah, that's I want to get good at this.
It's already pretty impressive. I'm just gonna grab some tissues right now.
So now that I don't work this day, like I still it's like face off. You just pay off the application to sell it. Wow. How would that actually just get code that has to back
I need some people that are actually showing up on time for their actual schedule. Both these sauce on their face, description was too depressed.
Yeah, I was wondering what's the normal attendance? God, can you imagine if they did this last week?
Disaster. People would just be crying as soon as your talk was over. I think we're just out of energy this year.
Yeah, that's good enough.
Automation we've done has been too personal. People can tell.
Yeah.
It's work I gotta do. People are joining this stream. Oh, which it's not showing the soon.
I'm not even going to use this.
Whenever you're ready to start, give me a second to switch from this screen to just your screen.
Okay.
That's about all the feedback I need to use.
Okay, well, I'm ready to go.
Alright. Okay, everyone. Let's take some seats. Alright, we're gonna get started with the second talk now. So, we're gonna face the wrong way so I can hear your attention. Grab some food, sit down, and we're gonna get started with Chris. He's going to talk about programming language of the mind. Is that right?
Building a programming language of the mind.
Okay, cool. So, I'm not going to do much more than that. Thank you everyone for coming out tonight, and let's give it here for Chris. Yay!
How's everybody? Thanks to Code and Supply for hosting us tonight. I put this slide in the deck. I realized my faux pas when I got here, and downloaded the logo real quick. So yeah, my name is Chris, and I want to talk about building a programming language of the mind. It sounds like a really high and a technical thing, but I think that the concepts here are pretty basic, and it's all about realizing what other people are doing and internalizing that into your own mental model. So a little bit about me. I work at a tech company in Squirrel Hill called Modal. I've been working there for about 7 years, and then probably another 5 years before that, which has really given me an opportunity to work on a bunch of different technology over my career. And currently I'm doing some really quite awful things with reverse proxies and mashing web services and applications together, injecting CSS live through reverse proxies where I need to, and it's just I would hate myself if I read it. But anyway, I think about these things a lot, and I think about where we came from, and so and you know, I forget your name already. Brittany. So Brittany's, thank you for that presentation. That was awesome. And it was very, very forward-looking. My talk is going to be a little backwards-looking and more internal. So yeah, let's get started. So this is the cockpit of the F-16 fighter plane, and this had kind of the dubious distinction of being the first fly-by-wire aircraft or fighter plane, and at least in wide deployment. And what that means is that there was no physical control between the pilot making movements of the joystick and the actual control surfaces of the airplane. And so the F-16 was basically this new modern technological miracle of we can do more things than what is humanly possible by introducing a lot of technology and automation. But what the military found was that this comes at a cost, and that cost is basically the cycles that you spend thinking about all of this technology. And there's a problem that it's not related to the F-16 directly, but there's a problem in aviation. It's called controlled flight into terrain. And what that means is, if you can take a guess, it is when pilots crash perfectly good operating airplanes into the ground because they're not paying attention. And this is a problem in a lot of other arenas too. So it's a huge problem. So where I work, we do a lot of clinical documentation stuff. And this is a huge problem for physicians and other providers who spend 30 or 40% of their time doing non-patient work, working with documentation and other stuff. And of course, people like us, coders, it's basically abstractions on abstractions on abstractions, and where does the rabbit hole end? So I think these sets of problems are common to anybody who considers themselves a thought worker, and that's why I'd like to think about these. And I try not to get too profound. So hopefully, in this talk, I'm not going to try and oversell something. I'm going to offer a premise. I'm going to tear it down, and then I'm going to bring it back up again. So I was talking a little bit in the introduction about how we think and the problem of cognitive load. What the military is doing in later versions of fighter planes is trying to automate less and make the pilots actually focus less on stuff that's around them so that they can actually, fly airplanes. So this is an important problem. So, how can we as programmers reduce our cognitive load and actually perform better as developers? I always look back to my favorite book. This is the Pragmatic Programmer by Andrew Hunt and David Thomas. Anytime a junior developer comes to me, I take my copy off my bookshelf and said, please read this, because we're going to have discussions, and I'm going to tell you that select isn't broken, and I'm going to tell you a whole bunch of stuff. So this is for me, one of my favorite things to talk about. And actually, what they introduced this concept, and this is where I got it from, that you should learn at least one new language every year. So has anybody actually learned one new language every year through your whole? Well, okay, we got one hand. Kudos to you. I should have brought gold stars. I know I haven't. Because who has the flexibility to be able to actually use those new programming languages, the new techniques that you have every day at work? Usually when you're working on a project team, it's single stack, right? So, how often can you mix Haskell with Ruby and JavaScript, Node.js, C#, even down to like legacy stuff like COM programming and Windows API processing. So, this is where I came up with this hypothesis. And the hypothesis goes, learning new languages makes you a better programmer, even if you never use those languages in production. And I promise I'll try not to quote myself too much. That looks like I have a huge head. So actually, I posed this question to some people. I was at the Abstractions conference, which was awesome, by the way. It was great to have a technical conference here in Pittsburgh. So I posed this question to a couple of people that were there. And I said, can you think of a programming language technique or idiom that affected the way that you work in another language? So I thought this was a pretty interesting question. So the first person I asked, he actually responded to me with this. I'm not sure how learning new languages influences how I program. If I only had a hammer and discovered a screwdriver, it wouldn't change how I use the hammer. And adding a saw would not change how I used both of them. And if you recognize the name there, that's Joe Armstrong. He was at Abstractions, the creator of Erlang. So I was like, oh man, what does that do to my hypothesis? Okay, and this is from an online conversation that I had. And this person says, this is still Joe Armstrong going on. New languages are new tools. And at the end of the day, you need to know what problems are appropriate to use which technology for, right? And this is pretty straightforward, right? And as programmers, so we want to know when we have a problem, what's the right tool for that job? And what I'm saying kind of goes against that. What I'm saying is that when you learn these new things, it makes the tools and technologies that you do use, you use them more effectively. So I asked another famous personality on the internet, and he came back in and said, well, I'd rather ask what programming language design would help us a lot better than what we do now. We're currently terrible. Certainly in this day and age, the lack of safe meta definition is pretty shocking. And that was Alan Kay. So he didn't kind of directly answer it, but it's kind of along the same lines. And if you don't know who Alan Kay is, he did pretty much everything. So at this point, I was kind of like sad Charlie Brown. Is this a false start before I even got going? So now that I've said that, I'm going to spend the rest of the talk and try and convince you that this is a truism, that you should learn new programming languages and techniques, even if you never use them. And I'll lay out some reasons why I think that's the case. So, at this point, I was having a conversation with myself, and it kind of went like this. Is this some je ne sais quoi, I can't put my finger on it, idea that, is this something that's simply not kosher? Am I not putting my finger on the zeitgeist of, and I always murder the pronunciation of that word. Am I committing a faux pas? Are you all now taking Schadenfreude on me because I have no idea what I'm talking about? And if so, then mea culpa, my fault. Who here understood pretty much what I was saying there? Even though all of these things, they're not English words, right? But I would say having these words, and English is, I think, a really good example of taking really interesting topic thoughts from other languages and incorporating them into English. And I'm not sure if there are other languages that do this. A particular favorite of mine is Schadenfreude, and I actually learned how to say that for the first time when I was putting together this talk. Previous to this, I always thought it was pronounced Shade and Freud, but that's not correct. It's Schadenfreude. But what a great concept to understand that the pleasure that you derive from watching other people go through pain. So this leads me to one of my favorite words, and if it's possible to have a love affair with a single word, for me it would be this word, which is reify. So what does reification mean? And this is just from Wikipedia. Reification is the process by which an abstract idea about a computer program is turned into an explicit idea, data model, or other object creating in programming language. And this sounds very, very obtuse, right? So what does that actually mean? In short, it's making something a first-class citizen, right? And we can go back to really old languages that do this, like C. So what concepts does C reify? And for me, it's all about pointers and pointer arithmetic, right? If you're moving from the first generation programming languages into the second generation programming languages like C, being able to reference and dereference and knowing that there's syntactic sugar for array manipulation, like a subscript I array manipulation is just syntactic sugar for pointer arithmetic. And for a long time, I had no idea, even though I read the Programming in C Bible, I had no idea that was the case. And when I did find that out, it was kind of like an epiphany, kind of peeking beneath the covers, right? So this made me look at pointers and pointer arithmetic in a little bit of a different way. So how many of us write C for a living? A couple of hands go up. I like C a lot. I'm always surprised how popular C is still on like the language rankings on GitHub and everything. So I asked myself, if you were a C programmer, what would you take away from this talk? Because what C is kind of, it's an established language. You don't often hear about new things coming into the world of C. But here's one illustration that I think is probably 20 years old at least. So if you wanted to think about object-oriented programming in C, how would you go about it? And there's many different things that make up what object-oriented programming is, but I think one of the fundamental ones is both the data and behavior in the same kind of object. And this is a struct that kind of does that. This says, okay, well, I have a string, and it has some data, and I have a length method on it, right? And this is a pattern that you can use in C. So even though C is not object-oriented in any way, you can use C like it's an object-oriented language, and kind of use it like this, where you say, okay, well, I'm going to make a string. I have this constructor thing that's actually making this, and I can use it like it has something that has behavior. And that to me, the concept of being able to lift things that you know and apply them somewhere else is kind of cool, right? Where else do we see this? We see this in interfaces. So you could call header files in C interfaces, right? You could call pure virtual things in C++ interfaces. But not until you get to Java, where you have this thing that's called interface, do you start to really internalize the idea of what an interface is. Other things that Java does. So getters and setters. Who here has written Java? Oh, great. You're gonna love some of this. Who loves writing getters and setters? Yeah, nobody. But you know, what are you going to do if you're a Java programmer, knowing that there are other things nowadays like properties in C# and Scala case classes? What are you going to do? There's new and better ways to handle this kind of stuff. Like, you know, here's just an example of you know, how easy this is in Scala. You know, defining this in 3 lines, which would be 25 lines or more in Java. And basically, what I said is, you know, I learned to stop worrying and use just public fields. You know, when I write Java now, I don't use getters and setters. I just use public fields, because if you got to change the code, you know, people will say, oh, well, you're not abstracting it as much. But, well, you know, how often do you actually go back and change that, right? Another concept, idiomatic. I love the word idiomatic, and I guess it's my second favorite word. Idiomatic programming, for me, is that moment when you're learning a programming language and you say, oh, that's how they do X and Y. And you say, okay, well, you know, I kind of understand this now. So I love these little epiphanies of idiomatic programming. Like this little monster. And for the rest of my career, if I never write this again, I will be a very, very happy person. Because who has ever written code like this? Okay, I have some things. I'm going to iterate until the end, and I'm going to go by one. I'm going to get each thing. I'm going to do something to it. I'm going to add it to a new thing, and I'm going to return it. If I could copyright this and make money off of it, I would be a pretty rich person. This is terrible. This is such low level. You know what? You show someone who's not a programmer this line right here. What does this mean? We've got some semicolons in. We've got 3 statements. You know, there's no expressions anywhere. This is just. It's just garbage. And you know, now we have new ways of thinking about this stuff, like in Python, where you can do just, you know, where it maps more to English. For everything in this list, do stuff to it, and then return it. And if you were to learn that Python method and then go back to like Java, you probably write it more like this version than like this version. And if I never ever write something that looks like this again, you know, I'll be a very happy person, because I can't go back. Once you start writing like this, it's very hard for me to even just think about all of this low-level minutia anymore. And I was anticipating someone in the back going like, oh, what if you have an index and you need to count the index? Well, Python, they already thought about that, right? Okay, so functional programming. This is not a functional programming talk, because the way that functional programming talks are usually like, oh, well, functional programming is simple, like monads are just monoids in the category of endofunctors. And I remember when I first was learning what monads were, I went to the Wikipedia article, and it had this still in the first paragraph, and like every word was underlined in blue. And I don't know if you read Wikipedia like I read Wikipedia. I go to the first link that I don't know, and I click on that, and I read until I go to the first link on that page, and I click on that, and then I click on that, and then I click on that, and then, you know, 2 hours later, I still have no idea I still have no idea what a monad is. The abstraction was just too much for me to wrap my head around. But if you start from, more simple realizations that, for me, functional programming is just reasoning over lists and sequences. And I think that's such a core thing in programming, that everything is just a list and sequence. Like a program itself is just a list of statements, right? And when you think about being able to manipulate lists and sequences in efficient ways, then we start to discover these functional programming things, and you don't have to worry about lambda calculus, and you don't have to worry about what the actual definition of these things are. You start to internalize it because you can see what it's doing. One of my favorite singers, I guess not really my favorite singers, but I like this guy, Frank Sinatra. But I'm not going to talk about Frank Sinatra, the singer. I want to talk about Sinatra, the framework. And coming from a Java background and writing servlets, who here has written a servlet in Java? Okay, I'm sorry, my pain goes out to you, and I'm actually going to talk about what Sinatra does in Node.js, because I think this is amazing. What you can do in just a couple lines of Node is, for me, coming from the Java side, starting up a web server, listening on a route, and returning data. Before Sinatra's, this was a whole big, complicated thing, and now I can't go back. I can't go back and do it the old way anymore. I've internalized this new way of doing it. I only just have to say, oh, listen here and send hello world. And this is my favorite slide actually in this whole deck, because you can actually run this slide and it's a web server and it returns you something. And actually, so a neat little tidbit of the presentation is that all of the code's in 24 point font. So I can't fit a lot on each of these slides. And what this does so succinctly in what, 7, 8 lines of code, it literally, it blew my mind. And please don't laugh at me for my use of corny gifs. I think there are only 1 or 2 more of these. So yeah, it changed the way that I program, because now I think it was, who is it at Sun Microsystems that says the network is the computer? If we make network access like this first class in every language everywhere, then the network truly is the computer, and it really just changes the way that I think a lot about stuff. So a lot of things that we were just talking about, like DevOps, I love listening to new DevOps things, because we're talking about reifying a whole new class of activities into our development sphere, like some of this stuff. And my favorite part about this next slide is how old some of this stuff is. So Perl had Saipan back in the day, right? And that allowed you to go get Perl modules. So you could have your little program, and then you could install everything from the command line. And before that, you just had to manually go and grab sources. It was really, really tedious. Ant resolve, npm install. These last 2 are my favorite. This was kind of like a precursor to this next one, Docker run. Now we're abstracting away the operating system itself into our software package as a dependency. So this was another moment to me where I said, okay, well, I'm thinking about my dependencies, and my dependency chain goes all the way down to the operating system itself. And this is what we can do now, and it enables really, really cool DevOps things like this, where I just want to run this thing, and I don't care where it runs. Just put this out there somewhere. Here's how to do everything that we need. And for me, this was another mind-blowing experience. I can't go back to the way of manually packaging, manual dependency help, having to manually do all that stuff. How do we get anything done? And so if I was sitting as a Java developer or as a C developer, I would try and figure out how do we use this stuff in this new world, because we've reached a new level of understanding. Learning these new technologies really changes the way that we do things. So here's another blast from the past kind of concept for pipe programming. This is a really odd-looking construct that just says, okay, I want to do A, I pass in my value to A, and then I want to pass that result to B, and then I want to pass that result to C. So, a lot of you who are familiar with functional programming languages, that kind of looks familiar. People who started in often the iterative way look at it a little bit more straightforward. First I want to do A, then I want to do B, and then I want to do C. Well, in our new world of asynchrony and multi-threading, there are a ton of problems with these, especially if we're going over networking boundaries, right? So wouldn't it be great if we could just, explicitly state that order in which we do things and not have to worry about, this to me hurts my head. It's like looking at something backwards, and this is just a lot of crap to say, this is the order in which I want to do them, and extract away the little minutia about how we're actually going to do that. And languages now, like JavaScript, like, okay, well, promisify everything, right? Everything is promises. And you're seeing now promise-oriented programming in a whole bunch of different languages now. And this is something that you wouldn't really have noticed 10 years ago, but now you understand it. You hear about it in JavaScript. You hear about it in Node. You want to use it in other places, and you can even do fancy little symbols like I think this might be Scala Z. Is that anybody a Scala person?
They do that in Elixir.
Sure. I think that there are a finite number of ways to express this idea, and I think it's becoming more and more common to see this across languages. Especially this one with the little arrow and this one with the funky little arrow. I see them in more and more places. So pipe programming, this for me is pipe programming, and it goes back to like Unix. Okay, well I'm going to pipe cat to less, and do something at the end. We have a non-trivial program. So I'll stop here for a second and talk about this picture. We have a library at work, and we can get books for the library. And I said, oh, okay, I want the art of computer programming for our library, because I love the way that it looks, and I know that no one is ever going to read it from this direction all the way to that direction. I don't know. I think it's a little piece of computing history, and if you have a specific problem, you can go and read about what Knuth said. But even Knuth, this is one of my favorite stories. Back in I think the 70s, this guy John Bentley said, okay, hey Knuth, can you write me a thing in your newfangled what's it called when you're doing documentation? Literate programming. Write me a thing in your this new literate programming where the documentation is a first level concept, and you can say what you're doing and you intersperse code. Solve this problem for me. Read some text, determine the most frequently used words, and then sort them and print them out along with the frequencies. So Knuth did this. He went out and he did this, and he wrote I think like a 7 or 8 page long programming, all in literate programming. This is the same guy that invented typesetting in order to actually write this book. Talk about going like deep dive level stuff, right? This was a really cool solution. He actually came up with some novel data structures, and so this John Bentley guy, he went around to some other people, and a Unix guy said, okay, well, I'm going to do it like this, where I'm going to tokenize everything and then convert it to lowercase, and then sort it by uniqueness and count. And at the end, this does exactly what Knuth did in 8 pages. And this guy doesn't even, Doug McElroy, he doesn't even have 4 books on basically how to program. So, I imagine it kind of went down like this, where, Doug McElroy comes running in, he lays down the paper, and he's like, oh, hey, I did this in like 5 lines. But that probably didn't happen. But yeah, it goes back to the Unix philosophy, right? Where you make each program do one thing well, and then expect that you're going to feed the output of one program into another program. And this concept like goes back way back, right? And I think about this every now and then when I think about the difference between how we program in Unix type environments and how we program in Windows. And then I think about macro frameworks versus micro frameworks, and it's kind of the same idea. So is the difference between Unix and Windows kind of like the difference between Angular and React, where you have big things versus smaller things that are more modular and composable. And I'm not saying one way is better than the other, because both of these things have stood the test of time, at least on the left hand of this equation. And I'm not saying please don't use Angular because it's big and monolithic, but I'm just saying, hey, are some of these things the same thing? And I especially see this now in Node land, where if you run npm install, you get like 5,000 projects, almost literally downloaded, right? And my favorite story about here is, who knows the story about pad left, right? The library that literally the only thing it did was take a string and pad it a certain amount of characters. And the story was the author, he decided, hey, I don't like the way that this code's being used. I'm going to unpublish this. And it broke everything, because the transitive dependencies, it just broke everything just because of this little tiny little thing, right? Called pad left. So obviously there are pitfalls that we have to be careful of, but we're not going to go back to the huge monolithic thing. Okay. Who has seen a little dialogue like this before? I don't know if you can see it. It says, an error has occurred. See error log for more details, java.lang.null pointer exception. Null pointers, man. I don't know what you could say about this other than, I guess I'll just redirect it to the guy that kind of invented null pointers. And he called it a $1 billion mistake. Do we need null? Would the world not be better if everything was safely dereferenceable? If all the values that we thought had a value actually had a value? Why can't we live in this world? Because I think once you start to live in this world, then you stop worrying about null checks and you start just worrying about transformations of all of your data, right? And you start to see this in some languages like Scala, where you say, okay, well, I'm not going to return you a value. If I can possibly return you nothing, I'm going to return you a higher kind of type that says, oh, well, either I'm going to return you something or I'm going to return you nothing, and then you can safely transform on that. And then once you kind of wrap your mind around this, then doing null checks on every single return, it just seems so barbaric. So I think that's about all the examples that I have for today. I'll just leave the presentation with some closing quotes. A language that doesn't affect the way that you think about programming is not worth knowing. And this is a quote that actually started me on this journey. I heard this at Abstractions also, and I had to look up who said it. And this really concreted this hypothesis for me that we shape our tools, and afterwards, by using them, they shape us. So thank you for coming along with me on this journey. That's the end of my presentation, and thanks for listening. Questions?
You say use one of the last slides as an example. You say that explicit node checking is barbaric. Yet the code you were showing was a dressed up node check, where it's forced on you by the language. The type of matching in order to compare against none is